Good day, guys. So, continuing with this problem, we have a point P on the perpendicular bisector of the line joining two objects of equal mass, separated by a distance 2a. And we determined in the previous video that the gravitational field was directed along the axis, and it depended both proportionally on R and inversely proportionally on the special power R squared plus A squared to the 3/2. Now, they request two elements here that we need to analyze. Explain physically why the field should approach zero as R approaches zero, which means if we move point P to the left, making it closer and closer to the origin, then your field should be less and less. And second, prove mathematically that the answer to part A behaves in this way. So the other day we were discussing that the field caused by the presence of these two masses on point P ends up being a vector going directly along x-axis like this, and this field has a magnitude of 2gmr divided r squared plus a squared to the 3/2. It's negative because it's pointing left, and it's completely horizontal, hence the I vector over there. Now, physically speaking, what is going on that causes this field to be smaller and smaller as we take an R that is ever and ever smaller? Let us write our gravitational field over here. That's G. And let's consider what's going on as your point P moves to the left to positions like this, etc. So, the important thing to consider here is that the gravitational field is always acting radially from the source masses. So, over at this point, what you're having is a gravitational field in this direction and a gravitational field in this direction. Now, it's a little hard to see, but it's easier on the second part, where you can see that this is shifting angles. And as you approach the origin of this model, the angle theta that we're using is larger and larger. Now, if you remember, the two components that you're adding are the x components. And we know that as theta approaches pi-halves, as theta approaches a right angle, then gx, which depends on the cosine of the angle, becomes 0. Which means, physically speaking, that the x components are shorter and shorter, and the y components become larger, but they don't matter because they cancel each other. They're going in opposite directions. Over at this last point that I drew, you have very long y components that cancel each other and very short x components that are adding to a very small amount. So that's the physical reasoning. What is the mathematical situation? Well, you can consider that if R approaches 0, then G is a function of R, which is -2 capital G, which is a constant, m, which is a constant, r divided r squared plus a squared, which is a constant, to the 3/2. Now there is no mathematical reason why r cannot be 0. So you can tell that g at position 0 is equal to negative 2gm times 0 divided by 0 squared plus a squared to the 3/2. And that's 0 over a cubed, which is 0. So the mathematics agrees with the physics of this situation, and at the origin of your frame of reference, the gravitational field is 0.